Hi, hello, welcome back to my YouTube channel. In this video, we are going to see about shell and tube heat exchanger. What is a shell and tube heat exchanger? It is a type of a heat exchanger used in a various industrial applications to effectively transfer heat between two fluids. It consists of two large cylindrical outer shell and a series of a smaller tube or pipe connected within the shell. This allows a fluid to transfer a heat without a direct contact, and it is also used in a power generation and industrial process and oil and gas, etc. Basically, a shell and tube heat exchanger is a type of a heat exchanger which used in various industry applications, which has a large cylindrical shell and has a series of pipe which connected in the shell that helps to transfer a heat from one farm to another farm without direct contact to them. And let us see the working of a shell and tube heat exchanger. A shell and tube heat exchanger consists of a bundle of enclosed within a shell, one fluid flow through the tube, which is a tube side, while another fluid flow over the outside of the tube, which is a shell and tube, and heat is transferred from the one fluid to the another through the pipe valve. So first, a fluid flow. One fluid enters the tube, usually called a tube side fluid, while other enter the shell, usually called the shell side fluid. Next, heat transfer. Heat is transferred through the tube valve from the hot fluid to a cold fluid, depending on the application that requires. And next, a shell side versus tube side. The choice of which fluid goes in the shell or tube depending on the factors such as temperature, pressure, and the nature of the fluid. So basically the flow of fluid will be depending on the temperature and the pressure and the nature of fluid that react to the process. First, let us look at the pictures of a shell and tube heat exchanger. First, apart we have a header, and second part we have a fluid one inlet and outlet, which we called as a tube side fluid. In a header we have a divider which divides tube side fluid inlet and outlet, and we have a shell side fluid inlet and outlet, and we have a baffles which helps to turbulence of a flow and which maximize the heat transfer of a fluid. So as we said, in the working of a shell and tube heat exchanger, first fluid one, which is known as a tube side heat fluid, so enters and flow in the bundle of a small tube or pipe. And from another side, we have a shell side fluid, which enters a flow of tube. So both the tube and the small tube contact indirectly transfer the heat with the help of baffles. Baffle is nothing but made up of yeah, it's a plate. It's made up of a steel, which helps to transfer heat from one to another. So from fluid one inlet, which called as a tube side fluid, goes out with a warm temperature, and another side of fluid two outlet, which is called a shell side or full side fluid outlet, which comes in a warm temperature. In temperature will be less when inlet compared to inlet, outlet temperature will be less and warm. So this is why working of a heat exchanger will perform in the industry process. Let us look at the application of a shell and tube heat exchanger. It is used for heating or cooling process fluid in a chemical manufacturing. So it is used in chemical manufacturing for both the heating and cooling process. And next, commonly employed in a power plant for condensing steam, cooling turbines, lube oil, or other heating exchange process. So it is used in a power plant for condensing steam and cooling and heat exchange of process. And next, it is utilized in refineries for a process such as cooling high temperature oil or condensing vapor. So this helps for cooling high temperature oil or condensing vapor. And next, it is applied in HVAC system which is a heat ventilation and air conditioning system, where heat is transferred between a refrigerant and air or water, which help to circulating air in the buildings. And it is used for pasteurization and sterilization process in food and beverage production. So usually it prevents food from bacteria and improve the quality of the product. And next, it found in various processes, including cooling, compressed gases, and condensing vapor as well. Let us look at the advantages of a shell and tube heat exchanger. The design allows for efficient heat transfer due to the large surface area and the counter-current flow configurations. So it provides efficient heat transfer due to the large surface area and the counter-current flow, which both the fluid will counter each other. So it gives efficient heat transfer. And next, it is suitable for a wide range of application across different industries. It is used in many industries and a wide range across different industries. Typically built with a robust material, enhancing the durability. So the strength and durability of a strain shell and tube heat exchanger will be high durability. And next, it is suitable for a high temperature and pressure application. So it is due to the build of a shell and tube is high durability and withstand a high temperature and pressure applications. It can be easily expanded by adding or removing a tube to adjust the capacity. For expanding the heat exchanger, it's very easy while we're adding up tubes or removing a tube for adjusting a capacity. It can adjust by adding or removing tubes in the shell. Let us look at the disadvantages of a shell and tube heat exchanger. The design can be more complex compared to some other heat exchanger, they potentially leading to a higher manufacturing and maintenance cost. The design is more complex because handling a more component and using both the small tubes and big tubes as well. So obviously the manufacturing maintenance cost will be high. It's because of advantage that gives in the process. The shell and tube heat exchanger require a space compared to a compact heat exchanger in a certain installation. While we compare to other types of heat exchanger, shell and tube has a large surface area. It is difficult in installation with the compact space in industries. And next, in application with the low temperature difference between the two fluid, the thermal performance may be limited. When a low temperature between the two fluids, the thermal performance may be limited. Outlet temperature of a fluid will be less in a low temperature difference between the two fluids. And a tube side fouling and scaling can occur, requiring a regular cleaning and maintenance to maintain the efficiency. As we said in the first point, the maintenance cost will be high. It's because of fouling and scaling in the tubes. In a shell and tube, we can remove easily a head and the smaller tubes which connected in the shell, which need regular maintenance and cleaning to maintain the efficiency of a heat exchanger. This is due to handling of a fluid, so obviously it occurs a fouling and scaling. In a summary, shell and tube heat exchanger are widely used in various industries due to their efficiency and versatility. However, their application should be considered factors such as space constraint, complexity, and a need of regular maintenance and cleaning. And the choice of a heat exchanger types depending on the specific requirement and application and trade-off advantages and a limitation comparison. And that's all about the shell and tube heat exchanger. Thanks for watching.